take it a little slowly here. I know people aren't joining. Cameron, I'm live streaming. You want to come join me and but you won't have to do the math. You don't even have to watch the math. Just tell me what's coming in, if there are any comments, if we have any people watching. Or if you want to, can you record me as well?
Well, I'm playing this flying game.
Pause the game.
No,
Dang it. Bro, pause the game.
I can't pause the game.
Alright. So we're going to start off with the integral of tangent x dx. Oh, that pen sucks. What are the good pens? Here's a good pen. So, I know it doesn't look like this is that complex, and it's not that complex. But we can change this to the integral of sine x over cosine x. Oh, I hate Wolfsons. And we can let u equal cosine x, and when we take the derivative of u, we get negative sine x dx. And now, usually you would write this as du over dx, move the dx over here, and it doesn't look like the only thing we can manipulate algebraically, but it just works, and I don't know why. So, I don't really know, and I can't really give you an explanation either. So for the moment, we'll just live with it. So when you do this, you get integral of negative 1 over u du, because the du is the sine x dx right here. And the 1 over u is when you replace this with 1. And since we have a negative, we can... Oh, that looks like a theta. Take the negative out of the integral and go 1 over u du. And when you do this, you get the negative natural log, and since u is equal to cosine x, you substitute cosine x in for u. And don't forget the absolute values, because trig functions can be negative, and you can't take the natural log of a negative number. And then we're done. That's my favorite integral. How? No one's watching. Can you watch? Actually, no. You don't have to watch. I just want you to be here for emotional support. That's number 1. Done. Alright. Oh, you can also change this to the natural log of absolute value of secant x dx equals c. I just like adding the dx. You don't have to. You know, it's weird because no one's here. So now, let's take this equation to the middle of the board, actually. Cameron! I need you to tell me if I'm blocking the whiteboard.
You're not.
X to the 6 minus 1 is... Dude, you should probably turn that down. Is equal to 0, okay? So what we're going to do is we're going to have plus 1, and plus 1 and negative 1 cancel out, plus 1. X to the 6 is equal to 1. And when we do some quick testing, we get x plus 1 as a factor, and x minus 1 as a factor. However, we can do a bit more with this. So these are the principal and actually real solutions, 1 and negative 1. So let's do some synthetic division. Let's do some synthetic division since we have x minus 1 as a factor, and that will get us our positive 1. and we carry down here, we divide by 1. Get x to the 6, 0, 0, 0x to the 5th, 0x to the 4th, 0x to the 3rd, 0x squared, 0x, and negative 1. One times 1. It will be 1. 1 times 1, 1. 1 times 1, 1. 1 times 1, 1. Oh, you bring this down. 1 times 1, 1. You bring this down to get this as well. 1 times 1, 1. Negative 1 plus 1 is equal to 0. And since the remainder is 0, we can take this, and this is our new equation. You decrease every power, and this is x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x, and the constant 1. So now that we have that, x to the 5th, is equal to 0. Now we set this second function here. X squared. Oh, I forgot the x squared term. X plus 1 is equal to 0. And since we've established negative 1 is another solution, now do x plus 1, and when we divide by negative 1, all the coefficients are written down, 5, 6. Yep, there's 6 coefficients there. You bring down the 1. Negative 1 times 1 is negative 1. And then this gets us a total sum of 0. Negative 1 times 0 is 0. You get 1. Negative 1. And then you get 0. Negative 1 times 0 is 0. 1. Negative 1 times 1 is negative 1. And you get 0 for the remainder here too. So you get x to the 4th plus x squared plus 1 is equal to 0. And you can... Hi, Mom. I'm doing a video. So you can factor this as the difference of 2 squares. X to the 4th plus x squared is equal to negative 1. And since we have this, we will have imaginary solutions. Factor this is x squared minus negative x squared is negative 1. So you have x squared minus this. A minus b, b is negative. X squared plus x squared minus x. Set both of these equal to negative 1. Solve for them separately. Y'all can still see that, right? Yeah, y'all can still see that. And I should erase the board, but this is a lot of work and I don't want it disappearing on me. So I'm just gonna sit down here and we're gonna do x squared minus x. And we move this to the other side. Do the same for this equation over here. Plus 1. X squared plus x plus 1 is equal to 0. We set both factors equal to 0. And we use the quadratic formula because completing the square would be... completing the square would leave us with a fraction here. I don't like that. So here we put the negative b, which is positive 1. And we are solving for this equation. Plus or minus square root of b squared, which is negative 1 squared, which is just 1, minus 4, and both coefficients are 1, over 2. And this is it here. 1 plus or minus, this works out to negative 3, square root of negative 3, and since this is a negative, we write that down as an I over 2. And these are solutions for x as well. This equation now, if we solve for this equation, that looks like it'll have to erase the board. Actually, you know what? I can work these out up here. Negative 1 plus or minus root of b squared, which is 1, minus 4, 1, 1 over 2. And if you do this, you get negative 1 plus or minus I times root 3 over 2. So these are our solutions. X is equal to this, and x is equal to this. Oh, it looks like a square subscript, superscript. There's our 6 solutions for x to the 6 minus 1. 2 reals, 4 complex solutions. Hope you learned that. All right, we got 1 viewer. Thanks to that 1 viewer. Can I get a... Never mind. Okay, thank goodness, that's the right marker. Okay, so what we're going to do next is we're going to take a derivative. X squared using the definition, which is the limit as h approaching 0. I know I'm yapping, guys. X plus h, because the definition is limit is of f of x plus h squared minus x squared over h. We open this up, x squared plus 2xh plus h squared minus x squared. And you see this and that cancel. And we put this over h, and don't forget to write the limit down again. Otherwise your teacher will mark points off here. 2x, actually I can do this up here. And when you see, we can actually factor out an h from, and we get 2x plus h. And we see this and that h cancel. So really we just have the limit as h approaching 0 of 2x plus h, and since h is equal to 0, 2x plus 0. So the derivative of x squared using the definition is 2x, and we are done. There we go. How is that necessary? How y'all doing? Yo, what up? What up, gum? I didn't see your message. I'm sorry about that. So here's how a Lambert W function works. A Lambert W function is... Huh? Oh, that was you? When we have the fish times e to the fish, when we apply the Lambert W function, we just get the fish back. We get the fish. Oh, that's a horrible fish. I've disgraced humanity. So that's what a Lambert W function is. When we take the Lambert W function of e to the fish, fish times e to the fish, you get the fish back. And that's a Lambert W. That's a Lambert W function, kids. I just realized I'm behind the camera. So, what we're gonna do next, we're gonna solve for this square root equation. X square root of x squared plus 3 dx minus 2 is equal to negative 1. So you square this, you square that, you get 1. X squared plus 3x plus 2 is equal to 1. And you subtract 1, subtract 1. X squared plus 3x plus 1 is equal to 0. It's not factorable. It's not factorable. So quadratic formula, negative b plus or minus the square root of b squared, which is 9 minus 4, 1, 1 over 2, yep. 9 minus 4 is 5. We get negative 3 plus or minus the square root of 5 over 2. And let me tell you, these solutions are not correct, because this is a negative number, and a square root can't output a negative number, because when we take the under root symbol, we get the absolute value of the number, and that's why it cannot equal a negative. No one who's watching my videos will understand this. Unless you do understand it. If you do understand it, if you feel free to explain in the comments. Alright. Huh?
You still recording?
I'm still recording, but feel free to step in if you want. It doesn't matter to me. Who?
You hit pause.
Oh, I might be able to pause it. You know what? I've been recording for 20 minutes. I'm gonna just